Okay, so today we're looking at parallel and perpendicular lines, and hopefully before this you have considered the idea that parallel lines are going to have the same gradient, because if they're parallel then they both rise at the same rate. So the rise over run is going to be equal. So parallel lines, gradient M1 is equal to gradient M2. Now the one that is perhaps new to you is perpendicular lines. Now remembering that perpendicular means that there is a 90-degree angle in between the two lines, then what we know is that M1 times M2 is equal to -1. So if you take the first gradient and you multiply it by the second gradient, you should end up with -1. Now the other way that this is sometimes written is that M1 is equal to -1 all over M2, and the reason we do that is because quite often, instead of being asked to show that these are perpendicular, you will be asked to find a perpendicular gradient. So if you're given one gradient, you can find the other one using that, but it doesn't matter which way you remember it, because if you remember M1 times M2 is equal to -1, then you can just solve the equation very simply. So this is the way that we're going to use it. In junior school, you would have been asked to pick the parallel lines and find the ones that both had 5 as the coefficient or something like that, but we'll look at things slightly more complicated now. So find the equation of a line that is parallel to y equals 3x minus 2 and that passes through the point 5, 11. So we know that the gradient is going to be 3 because it's parallel to the line y equals 3x minus 2. So we know that the gradient has to be 3. And we know that it is passing through this point 511. So hopefully after having completed exercise 7.5, you are able to say, oh, I need the point gradient formula. So write it down. Y minus y1 is equal to m outside of x minus x1. So substituting in, y minus 11 is equal to 3 outside of x minus 5. Expand out your brackets, and then they've given us the first equation in the gradient intercept form, so I'm going to give my answer in the same form. So y is equal to 3x minus 4. In this one we're being asked to show that these two lines are perpendicular. Now the tricky bit is they're given to us in general form, so we're going to need to do some algebraic manipulation in order to find out what the gradients of these lines are. So we're going to start with the first line, 5x minus y plus 2 is equal to 0. So I want this to read y equals, and I have this -y here, so if I add it onto both sides, I get y is equal to 5x plus 2. So what that means is that my gradient is equal to 5. So that's the first gradient. Now I'm going to consider the other line. So now I have x plus 5y minus 4 is equal to 0. So we need y to be positive for y equals mx plus b. So I'm going to keep my 5y as it is. So then I get minus x plus 4. And then because this is 5y and I just want y, I need to divide through by 5. So y is equal to minus 1/5 x plus 4 over 5. So then my second gradient is minus 1/5. So then what we need to do is say, well, m1 times m2 is equal to 5 times -1/5, and that is equal to -1. So therefore, the lines are perpendicular. Now something I want you to consider here, look at these two equations. So we have 5x minus y plus 2, and we have x plus 5y minus 4. And these lines are perpendicular. So let's have a look at the coefficients. In our first equation, coefficients are 5 and -1. And in our second equation, coefficients are 1 and 5. So when the line's perpendicular, what happens is the coefficients switch, because 5 over 1 is the reciprocal of 1 over 5. and one of them is going to be positive and one of them is going to be negative. So just something to consider when you're answering these. Double check and make sure that that's true for your perpendicular lines. Okay, so in this case, similar to the first question, we're being asked to find the equation of a line. We're given another line and a point that it passes through. But in this case, instead of being parallel to this line, it is perpendicular to this line. So there's just going to be a bit of an extra step. So the first thing we have is the equation for this line. So we have 3x minus y plus 7 is equal to 0. So we need to know what the gradient for this line is. So we want y to be positive, so we're going to take it over to the other side, and we're going to get 3x plus 7. So now I know that my gradient is equal to 3. But the line that we're looking for isn't parallel to this line, it is perpendicular to this line. So when we were talking about that idea that we can say, well, the perpendicular gradient is going to be -1 over this gradient. So what that means is that the gradient I'm looking for is -1/3. So I'm then going to substitute that into my point gradient formula because I know what point it passes through. So y minus y1 is equal to m outside of x minus x1. So I get y minus 4 is equal to -1/3 outside of x minus 1. Now you can expand out your brackets if you like, but you're going to end up with some fractions and some not, and too many of us make really simple mistakes when we do that. So what I'm going to do first is multiply through by 3 to get rid of my fraction. So 3y minus 12 is equal to minus x minus 1. So then I'm going to deal with the negative, so minus x plus 1. And then because we were given a general form of the equation, I'm going to give my answer in the general form. So we're going to bring that across and we're going to get x plus 3y minus 13 is equal to 0. So in exercise 7.6, you can do as much as you need. Good luck, and I'll see you in class.